So, everybody still awake? Good? Yeah, woo! Yeah, that's the energy. Okay.
Yeah, hi everyone. We're really excited to be here today because 3 years ago, like Helian and myself, we were here in the audience and we thought, wow, like one day we want to stand here on the stage, and yeah, here we are. It's really cool. And we want to show you how our story today about how we migrated a desktop application to the web. And yeah, let's get started. But before, who are we? Well,
Clicker?
yep. My name is Jakob Schröter, and funnily enough, my initials, JS, fit to what I'm doing since nearly 3 decades, because I'm started building websites when I was 11. And honestly, like with all these innovations happening every year, I still really enjoy doing it.
Yep. And my name is Helian Rivera, and no, I have not been working in human resources since I was 11. I've been a developer. I like it a lot. My passion is in web development, and I've been doing it for the past 10 to 12 years. And together with Jakob, we work at a company called KNIME.
So what is KNIME? KNIME is an open source data science platform. It's got released in 2004. And over the time, it grew to over 300,000 users worldwide. But beside the open source part, we also have commercial offerings, which are used by more than 150 well-known enterprises. Yeah, to me, this sounds pretty interesting. And when I joined KNIME 8 years ago, my front-end friends asked me, "Hey, Jakob, what are you working on? Like, can you send me a link? I want to see something." And honestly, I didn't want to send them the link. Because back then, KNIME was an 800 megabyte download looking like this. Oof. It's a Java desktop application based on Eclipse. But yeah, you get the idea here. Like KNIME is a visual data science tool allowing anyone to work with data, basically by building workflows, by connecting nodes and configuring them without coding. But you can code a bit if you want. It's very powerful and established, and because it's open source, has a lot of integrations and third-party integrations, extensions. But its potential is a bit limited, as you can guess, right? Because it's like the desktop application. And also our commercial customers, they ask us, hey, it would be much easier for us to manage this running in-house, right? If it would be a web application. So this is why we and some more developers got hired to transform this into a modern web experience.
Here you can see one idea of the early designs where we wanted to go in the direction. And these, of course, are just a couple of examples, but you can maybe sort of guess the complexity that the tool has, because the KNIME product is not just about building workflows. You can do a lot with it. You can execute them in the background. It can run through a lot of data. You can create visualizations, reports, dashboards, interactive data apps. It's software that's been around for a long time. So we had a lot of work ahead of us. But, I mean, maybe we can vibe code it. Sure, it should be easy. So we started the journey to build a new workflow editor, and of course, we first wanted to assess what framework to use, and spoiler alert, we chose Vue, because otherwise we wouldn't be here. And yeah, and I think one thing we liked a lot about Vue is the great DX, and Dragon was showing it earlier this morning, that there's this special thing about Vue, and once we started using it, it was really, really nice. And especially, it provides an easy onboarding for developers that don't have a lot of experience with front-end development. And because we come from there were a lot of developers with the Java background, this made it a bit easier for adoption. But of course, the most important criteria for deciding this was that the logos really fit well together. And this was we go for it. But of course, when we were getting ready to start the development of it, something else happened, and we had to.
Yeah, priorities shifted a bit in the company, because we realized that actually we had a lot of interesting content which was only available in the desktop application. So content like example workflows showing use cases, how to use KNIME to solve this and that, right? And to improve the visibility on the market, we wanted to put this content online and also make it indexable by search engines. And that's why the idea of building a content platform first came up. So we started looking into frameworks that could help us with that. And yeah, we knew we needed server-side rendering for the static content, right, for search engines, but also client-side rendering, because we knew also that this, likely we will add more features to this. It's not only about a static website. And further, the framework should be flexible for all the future upcoming things, but also be a bit of structured, right? So that when it grows, it has a bit of structure. So since Vue was settled already, we of course looked into Nuxt. And it was in a very early stage. I think we started with Nuxt version, a beta version of Nuxt 2. And yeah, we liked the direction it was going. It looked really promising. And of course, we did our final sanity check. The logos also fitted really nicely together. Back then, now the Nuxt logo looks a bit more rounded.
It's still a triangle, so I think it works.
Yeah, and Nuxt turned out to be a great choice. Over time, this platform grew to the main entry point for many of our users. And let me quickly show you how it looks today. So basically, you can imagine it like GitHub for data science. It's actually called KNIME Hub. And so you can search for workflows, you can collaborate in teams, but also we have enterprise features in this application, like, for example, being able to deploy workflows you have created as a data app. This is what we call some interactive app for business users, for example, but also deploy those workflows as web services, for example. We have many more features in there, but we cannot show them all. But we want to highlight some of the challenges we faced during the development. So yeah, it started small, but now it's a big enterprise front end with over 200,000 lines of code. It's deployed to multiple environments, software as a service, on-premise. And with this, there comes a high dynamic feature set, right? We have feature flags, permissions, licenses that you can apply. And also, on the backend side, we have many microservices that we need to handle all with one big front end. Luckily, with Nuxt 3, Nitro came in, and that helped a lot to improve on this side, and also to build a backend for front-end layer that we are using here. With all of this, and nowadays multiple teams working on the same code base, ownership and architecture gets a bit tricky. And this is what we are currently facing and trying to improve with a feature slice design inspired architecture. But after hearing Jakob's nice talk yesterday, and also speaking to Daniel, I think we will look into Nuxt modules and also Nuxt layers again and again.
Yep, but now we have the content platform, we can take a step back and we go back to the UI, and we want to finish the user journey. So we have this workflow. Wouldn't it be great if we have some way to edit the workflow? And that's when we came back to the workflow editor, which was the original thing we wanted to start with. But before we do so, we wanted to set for ourselves a few guiding metrics. For example, we know that we want to go to the web, but of course we still have to support a desktop application. So we want one single code base. We don't want to write everything twice. Second, we want to go for incremental adoption, because the tool has been around for a long time. It has a lot of features, and so it's very impractical to migrate everything all at once. We have to figure out a way that people can start using it while still being able to use the features in the legacy application. Of course, we also wanted to focus not on feature parity, but rather value parity. What this means is we wanted to assess what are the features that already exist, and individually take them one by one and say, okay, this is more aligned with the feature, with the future of the product, and bring those first rather than just yeah, let's just do everything. Importantly, we also must not break any existing workflows because the tool, like a lot of people are using it in their companies, they're running a lot of data through it. So we have to make sure that everything that used to work before still works in the new application. It has to be completely backwards compatible. And of course, last but not least, we can innovate because this is a good opportunity. We're doing a lot of things anew, so we can revise the UX, bring new features like new quality of life improvements. So why not do that? But still, I mean, with that said, we still have this Java application that we need to bridge to the web, and how do we do that? And of course, we need a browser to do that. In the beginning, what we did was like we experimented with SWT WebView. This is provided by Java. And what this does is just it spins up a native operating system browser. But under the hood, because it's using the native OS browser and the majority of our users are in Windows, that meant Internet Explorer 11. And this is not a good commitment to make. So of course, we looked into something else, in this case, the Chromium Embedded Framework, alias CF. And for those who might not know, CF is what's used under the hood by Electron apps. But we cannot do an Electron app because Electron apps have a Node backend, and we have a Java backend. So this doesn't work. And luckily, we found this company from Argentina called Echo, and they provide such a wrapper. They provide something called Echo Chromium, and this wraps around CF and interfaces very well with Java, specifically in our case with an Eclipse and PDE environment. And it also provides the communications that you can get to the UI. So what we did, we added this little button here. This is the classic interface. And what we added was essentially something we call the perspective switch. And when you click this button, what you see here, it's a browser being spin up with a very basic Hello World application. But this is now HTML. You're like using JavaScript, so now the world is your oyster, essentially. And so next, we can look a bit into rendering. So here, these are the main primitives that we have in our application. They're called nodes, KNIME nodes. And maybe from the get-go, you can imagine that HTML won't really work for this. So we went for the next best thing, which is SVG. And SVG had a big advantage for us. A lot of these nodes were already written in some form of another as components, as Vue components for the content platform, which was developed before. So we could reuse some of that code. And yeah, using SVG in Vue, it's pretty easy. It's like just like HTML. You can pretty much do everything that you can do in HTML. However, for us, this presented a challenge because set index is 3 in SVG, essentially because there is no set index. Everything is based on the DOM order. And luckily, Vue has this very nice feature called teleport, which we use heavily on the SVG canvas implementation to essentially retain a good component structure while still rendering the things in the order that we want it. Of course, after many iterations, this is kind of like how it looked like a bit in the future. Here in the background, we can see the web UI. This is still the desktop application. You can see in the background the web UI being powered by CF. And in the foreground, you can see that it integrates with the legacy features that already existed. This is a Java application. So we get to the state of mix and match, which was really good because it lets us like still develop things and just continuously improve. However, this is just a summary of the implementation of the workflow editor. There are still a few interesting challenges that we run into along the way, and we want to share with you some of those.
One of those challenges are our forms, because in fact, we have many forms in the application. For example, if we look at the screenshot again here, to configure those nodes, we have a form. And we have over 3,000 nodes. Most of the nodes are written in Java and some in Python. So we needed to find a way how to transform those forms into like this new like web form. And most importantly, the extension developers of KNIME, they should not need any front-end knowledge to do that. So we did some research and find a nice library called JSON forms. And with JSON forms, basically you define like a JSON forms schema describing the form that you want to build. And then there's a JSON forms renderer that can plug into your Vue components, and then you can render like your own components based on this scheme. Then again, like we created like a little SDK for Java and for Python, which allows developers to just annotate their Java and Python code, and the SDK then transforms this into a JSON form schema, and in the end, it will turn out into a nice web-based UI. And you can see the UIs, like the forms can be quite complex with some conditional logic and so on in there. Thanks to the mix and match Helian explained before, we are now able to ship those modernized forms already within the classic desktop application, right? You see in the back, this is like still Java, but in the front, there's a modern dialog. But also, we could combine it with the new workflow editor that we have built, right? So that we have the workflow editor, the new one, and also the new forms. Nice.
Yep, this is pretty cool. Unfortunately, there's still another problem. This window that you can see in the foreground is still running a separate browser instance. And because we know we want to go to the web, we still had another problem to solve, which was how to embed them at runtime, because we need to make them that they're all in the same window. And the reason why we have to do this is because, as we said before, we have a lot of extensions, and we do not know at build time what the extensions are. Only the user can decide what extensions they install. So a lot of these are generated at runtime, and we have to fetch them. This is kind of like what our initial approach looked like. So we had the main application. It's like the application shell that is running the main Vue application. And what it would do is it would fetch what we call internally a UI extension build. This would be a bit library build, and would be fetched at runtime and would be registered dynamically in the main application. And this worked for a bit, but slowly we started to notice some issues. For example, we started having like a lot of CSS scoping conflicts, because the reason is like both the main application and all of these UI extensions use a shared UI kit that we built in-house. And sometimes there were like code being written that would override some of those styles from the shared components. And because we're embedding everything into the same instance, the scoping conflicts would arise. And they were very tricky to debug and very tricky to predict when they would happen. So you would have like the UI loading something, and then all of a sudden the button starts to look a bit funky. Another problem we had was Vue version incompatibilities. The team that works, my team, we work on the main editor, but the teams that work on the UI extensions, they're separate teams, and they often have like different update cycles for their dependencies. So there will come times, for example, where we are using Vue 3.8, but they're still using 3.5 on their like extension, and when we pull that in, there's maybe a bit of an incompatibility there. And another problem was that in order to make this work, we had to expose the application, like the Vue instance, into the global window, which did not provide like technical difficulties, but it's still a potential security issue, right? Because it's just exposed in the window object. So we had to like take a different approach to solve this problem.
Yeah, so we again wrote a little SDK. This time we called it KNIME UI extension SDK. And this handles the embedding and the communication between the main application and those standalone UIs. It supports two modes. One is the iframe mode, and this, of course, has best isolation, best sandboxing, and also from a security perspective is the best. So especially for third-party extensions, this is the way we wanted to go. But it has one issue, and this is that you are tied to this visual frame, right? You cannot escape it, which is a good thing on the one hand. But we had use cases where we, for example, wanted to show like a popover or a modal dialog from out of those standalone applications, which should overlay the main application. And that's why we also implemented this shadow DOM mode, which basically renders a Vue application into shadow DOM. It also has some JavaScript and CSS isolation, so it works pretty well. And we use this for our in-house UIs that we build. Also, the nice thing with this is, like with both actually, but mostly with the iframe, is that we are not tied to Vue, right? We can load any kind of application in there. And that's what we use for our visualizations, where we use the Apache eCharts framework. All right. So with all of this that we described so far, we reached a very important milestone for us. And I think this milestone deserves a little drum roll, but you heard before that I played the drums, but unfortunately I couldn't bring my drums here. So I need all of you now to do a little drum roll with your feet, right? Can we do it? Let's start. Yeah. Yeah, yeah, a bit louder, a bit louder, a bit louder. Yeah, and stop. Cool. Yeah.
Thank you.
Thank you, really cool. I wanted to use the web audio API for something more or less useful one day. All right, but back to our milestone. With all of this, we finally had the whole application for the first time working in the browser in a usable state, right? You see, we dropped an Excel file here. Then we, you can see, you can inspect the data. You see the configuration, like our forms. You also see the visualizations. So the whole thing really is working.
Yeah, and we also have some AI features, by the way. Like it integrates with all the models. It does some stuff for you. But I think we've had enough of AI, so we're not going to show any of that.
All right. At this point, we also want to point out that really, like Helian and I, we did not develop this ourselves, right? There was like many developers at KNIME who are likely watching us here on the live stream.
Not alone of us.
They were all helping, and it took a huge effort to migrate this application, not only on the front-end side, but also on the back-end side, infrastructure, UX, on the product side, and so on. So yeah, because it's running on the browser now,
Yeah.
I can like respond to my.
No, wait. What are you doing? No, don't do it. No.
Why not?
You're gonna send your friends? No,
Yeah.
no. I think there might be still problems. You have to make sure things, because things can go wrong. Like.
Oh yeah, performance. Yes, actually, this is one of my favorite topics, and we indeed had some performance issues. Although KNIME provides like a way how to wrap like complex or split complex workflows into tiny pieces, they're called KNIME components. Guess what some users do? They build huge workflows. And you might remember that we're using SVG for this rendering, right? And with SVG, yeah, every element is rendered in the DOM. So the more elements you have, the slower it gets. And yeah, you can see here that the performance with big workflows was not acceptable at all. Luckily, Helian had a few ideas.
Yes. So we set ourselves to replace this approach. And of course, we first looked into a Canvas implementation. And at this point, we did not want to rewrite everything. So we wanted to look for some tools that lets us retain the same architecture that we had inside, but kind of like map from A to B. And we looked into, for example, some tools like Conva.js, which integrates great with Vue. But unfortunately, we did not have any meaningful performance wins in the POCs that we made. So we had to keep looking. And then we thought, OK, what about WebGL? And we found this framework called Pixie.js. And for those who don't know, Pixie.js is like a 2D rendering engine for game development in the web. It's pretty cool, very well maintained, like great performance. But it lacks a first-party integration with Vue. But the POC that we made with this, we had to raw dog it with vanilla Pixie, but it was really good. The performance was great. And we said, OK, what do we do now? But thankfully, Vue has this thing, the custom render API. And like I know there's some guys from Tres.js here at the conference, so they know about this because Tres is like using this to work. So we had to say, OK, maybe we have to write one ourselves for Vue Pixie, for Pixie in this case. But the Vue community also is great, and this already exists. It's called Vue 3 Pixie, and with this, we were able to get working. So we're back here. So let me show you how that looks. Here on the left side, we have the SVG implementation. This is a very simplified example. And on the right side, we have a WebGL snippet using Vue 3 Pixie in this case. And like most of the magic happens here. Like here in SVG, normally what you would do is you would bind your paths. But in the case of WebGL, everything happens on the render function, which is powered by a watch effect. So normally you have to draw all the things, but you can have your reactive dependencies in there. And whenever it changes, it will just schedule to the render batches that Pixie would like redraw on its next pass, and it would just get synchronized with the scene graph of Pixie. And of course, again, this is a very simplified example. There's many things that we had to do from scratch. For example, there was no CSS that we could reuse. So we had to style a lot of things. For some cases where performance was more critical, we had to like go a bit around and like, use directly Pixie. But overall, I think the results were really good. This is the same workflow that Jakob was showing before. Same amount of nodes, but in this case, the interaction for dragging is like very, very smooth. And like not only this was like a nice effort, but it also opened the door for future more performance optimizations because we are now in full control of the render output. So this is really good. Yeah, thanks.
Thank you. Yeah, to recap our journey, here, like a very rough timeline of our milestones that we had. In reality, they did partially also happen in parallel, right? The development of those milestones. But yeah, and now this year we are really looking forward to finally launch the in-browser editing officially. This is the next big thing we are going to release. Yeah.
Yeah, and of course, you know, like not everything that we did is user-facing. Like there was a lot of work that was happening behind the scenes. You're all developers, so you know like the story. We had to do a lot of like Vue 2 to Vue 3. This was really smooth. The API was very stable. The guide was like really easy to do. Nuxt 2 to Nuxt 3 was a bit of a anecdote, but yeah. And yeah, I think we also had like a few other things.
Oh yes,
yeah.
oh yes, yeah. And we still need to go to Nuxt 4, yeah.
Yeah, but I think in general, all these things are worth it. Like performance improved, the productivity improved, all these tools are moving in the right direction, so it was worth spending the effort to do that.
Yeah, and we have some more learnings that we want to share with you. I will start with the ones that didn't go so well, basically also like a summary. First thing, yeah, Helian mentioned it a bit, like the Nuxt tree migration was a bit tough for us, honestly. But partially, it was also our fault, because with Nuxt 2, and like, as I said, like we started with a very early version, right? We implemented quite a lot of custom workarounds for framework functionality. And all those workarounds, they fell on our feet when we wanted to upgrade. So a lesson learned was here, like try to stick to the framework, try not to work it around too much. Next thing, yeah, we underestimated what our users would do with the app, as you have seen regarding the performance. And also not isolating the embedded standalone UIs, yeah, didn't turn out that well. And one thing also I would like really like tell you or like hope you don't use it that much because it was a pain for us. Initially we used a lot of deep styles, as Helian mentioned, and they were a pain later on. So we try to avoid them now everywhere.
Yeah. Of course, on the flip side, there are many things that went well. Like for example, we focused on this approach of doing things incremental. It's really good for us, also for the users. We were able to get people testing things. And this combined with this mix and match state where we are able to like let people still use the legacy features combined with the new UI, it was very good for feedback. We kind of maybe inadvertently focus on this mantra to make it work, then make it good, and then make it fast, as indicated by the performance section. Maybe in hindsight, we could have looked into the performance a bit sooner. But of course, we're also understanding a bit the domain and like what we wanted to implement and getting expertise implementing this like new canvas. And like it was good that people could try it out and we at least at the end discovered this use case. And of course, importantly, listen to user feedback. But also don't get discouraged by it. Like we have a large forum in the community and people are very like passionate and vocal, especially because the tool has been around for so long. They have opinions about, like very strong opinions about like how things should work. And sometimes like they're right and it's good to listen to that feedback because sometimes it can get you a bit depressed. Yeah, and of course, we would not be here if it wasn't for like all the great many tools that exist in this community. So I'd like us to give it up for the open source community.
All right, that was our journey, our story. If you have any questions to that, or you are facing similar challenges and want to have a chat, feel free to reach out to us here today or online. And in case you're curious how we solved certain things, you can check our code on GitHub. And yeah, thank you all for listening. See you
Thank you.
around.